Question number 13. A uniform rod of length 30 centimeter, weight 5.2 Newton. Weight acts at the middle. So I'll write this as 5.2 Newton. Act here. It's attached to a wall at one hinge. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. Okay. The wire is at an angle of 40 degree to the horizontal. Okay. What is the tension in the wire? So he's asking you what is the tension here. Now what we do is, let me resolve this tension into two parts. One along this direction, the other along this direction. So here it will be T sine 40 and this side will be T cos 40. So I am not interested in this. Let me take the moment about this point because that's a fixed point, right? So therefore, if I take the moment about that point, now I can say this is your clockwise moment. What is the clockwise moment? Clockwise moment is, sorry, anti-clockwise moment. Anti-clockwise moment is T sine 40, force multiplied by this distance. What is the distance? Multiplied by L. Okay, is equal to clockwise moment. This is your clockwise moment, right? This clockwise moment should be 5.2 multiplied by L by 2 because it's at the half of it. I have not taken the distance also, not required for you. Okay, so this L and this L goes away. So I have T is equal to 5.2 divided by 2 sine 40. So I need just to find out this value. So if I find out this value, I can easily get the answer. Let us find this. So let me write 2 star sine 40. What is sine 40? Sine of, oh my god, I'm using this calculator. So sine 40, first find out sine 40 here. Sine 40 is equal to so much. Multiply this by 2. I get this value 1.28. I take the reciprocal of this 0.77. Then I multiply this by 5.2. I get the answer as 4.04. So 4.04 Newton. So which is the closest one? B is the right answer.